Hey, Vlad here, devinsidey.com. Welcome to the next video in the Scala playlist. We've already covered a lot of ground in this playlist. We talked about functional literals and the underscore syntax. We talked about subroutines and the array expansion. We talked about function composition. The manual one and the automatic one was functions like compose and then that comes straight from the Scala standard library. We also talked about higher order functions, specifically about functions that take other functions as the argument. We've also talked about by name parameters, and we even covered function currying. We sort of rushed through this. Today we're going to talk about closures, and they sort of go hand in hand with function currying. And function currying covers the other side of higher order functions. So function currying is about returning functions as a result. Also, in the next video, we're going to talk about the computer science view on this topic. Specifically, we're going to talk about the environment model of computation. So it's going to be a little bit more formal. All right, enough talking. Let's get started with this one. As always, we're in the virtual machine that runs Ubuntu, and we have Sublime on the left and SPT in the terminal on the right that runs our code. So what we're going to do today is we're going to start with a very, very simple code. We're going to have a function called add to 7, and it's going to take an integer, and I'm going to call it y integer, and it's also going to produce another integer, right? So it's going to take a 7 and add the y to the 7, and we're just going to print it out a few times. At the 7 was a y of 0, and we're going to do 1 and a 2 and a 3 as well. And let's see. So what we see in the terminal now is nothing spectacular so far, right? But you should start noticing that this 7 is sort of special. It's not being treated as this variable, and it has nothing to do with the fact that this one is a variable and this one is a literal. And in order to make it a bit more evident, let's move the 7 out in its own variable. So let's have a 7, which is an integer, and we're going to have a 7 over here. So now instead of the 7, we're going to have a 7 over here. So now we sort of have two variables, but one is somehow different from the other. It's being treated somehow differently. In fact, let's move it even further out. Let's put it as a parameter to the code function. Let's have it over here. Let's just completely remove it from here, and now over here we're going to say, okay, 7 is actually a 7, and now because it's actually so far away, it's actually not a 7, it's just another variable, right? So let's call it x. And let's call this function add to x. Right, so I just moved it out just to demonstrate that it's being treated like somehow completely different, right? It's sort of far away. It's being computed some in a different way somehow. So I'm just going to bring it back in. So again, this was just for demonstration purposes. So I'm just going to have a val x equals 7, and let's specify the type, or I don't know. I think as a beginner to Scala, I'm going to try to specify types more often than leaving them out. In the next few steps, we're going to see how the compiler sort of looks at this x differently as it looks at the y, and how you as a programmer also should look at it very differently. We're going to introduce the proper naming conventions, and we're going to define closures properly. So as of right now, I need you to understand that when the compiler reaches this point, this line, that it sort of doesn't care about the value. It doesn't care about the 7. It only cares about the x. It cares about the fact that it exists, and it cares that it has the type of an integer. And in order to demonstrate that, we're going to turn it to a variable. Let's turn it to a variable and just run it once. And now, just before calling add to x, or in fact, just before calling print line add to x, we're going to change the value of x. So we're going to say that, so for the first one, it's going to say 7, right? And for the other one, we're going to say that it's a 10, and then we're just going to bring it down. Before this one, we're going to say it's a 20, and now we're going to bring it down, and I'm going to say that it's a 30, okay? And just for the symmetry purposes, I'm going to also set it to 7 again, just to sort of demonstrate that it doesn't even matter which value is specified here, right? So it can be 1, 3, 3, 7, and it doesn't really matter. So what you need to notice is that the Scala compiler, or the Scala language, let's say Scala language, that it understands that that the place of x is important and not the value. Okay, and again, we're going to define everything in just a few seconds actually, and we're going to see that this is actually a closure because it closes over the x. So before we do that, let me just indent a few things a bit differently, just so that you can sort of see that add to x is sort of being passed as parameters to the function add to x, right? So x and y, they're sort of being both parameters to the function add to x, but they're different kinds of parameters. Okay, so let me do the same thing over here. All right, and over here as well. Let's do it like that actually. Okay, and have it over here. I'm just doing this for educational purposes, okay? So like that and like that as well. And it should obviously not change anything, right? So if you recompile it again, it runs and the result is exactly the same. Before we continue, closures are usually being referred to functional literals. So let's have a functional literal syntax for this. So instead of having that, we're gonna have a val add to x, and it's going to be a function that takes an integer and produces an integer, and it's going to be y, arrow to the right, x plus y. So the thing is that functional literals, they don't have named parameters, so this is actually not going to work. So let me mark that and sort of comment this out, right? So now the result should be exactly the same. So usually functional literals are called closures and not definitions, not subroutines. And let me actually indent this as well a little bit. So let me have this first, and let's actually switch them like this. So I just want to do something like this and that and that, and I'm also going to have another one, you know, because you might be new to functional literals, and let's have it like this. Okay. So and the next thing that we should do is we should decide which one we're going to choose. Well, let's choose this one. Let's stick to the def for now. So I'm going to comment out these two, okay? And because they're commented out, we can also use those things again, those named parameters, okay? So everything is still the same, but just for education purposes, I indented it like this. Let's actually do like that. Okay, so everything stays the same. All right. Let's start renaming things now and actually define closures properly. Okay, so add to x is what's known as an open term. So I'm going to press Alt F3 because I'm on Windows in Sublime, and I'm going to rename this to open term. And it's called an open term because it contains a free variable. So x is actually a free variable. So let me do the same trick. X is a free variable, and because everything is getting longer, let me put Sublime on the top and let me put the terminal at the bottom. And the next time we're going to run the code, we're going to need more hyphens. So this is what we're going to need. Okay, so we have a free variable, we have an open term. So the other variable, the y, it is called a bound variable. We already learned this before. Let me try this. That's not going to work. So I'm going to do Control D and this one as well. Okay, so this is called a bound variable. Right? Okay, so it's called an open term because it contains a free variable. And a term that does not contain free variables, right? For example, if we had something like 1 here, 1 plus bound variable, then the whole thing is going to be called closed term. And by the way, term is just a piece of code, right? So it's nothing special. You can think about it as an expression, right? Usually terms are simpler than expressions, but that doesn't really matter. So again, this one is called an open term because it contains a free variable, right? And at runtime, the computational object that is being created out of this subroutine is going to close over the free variable, right? So it's going to close the open term, and therefore this is where the name closure is coming from, right? Whereas this one, it is already closed because it doesn't contain any free variables. It only contains bound variables and constants, right? Actually, let's remove this one like this, and let's do the indentation properly again. So closures are really important, but I'm not going to be able to show you a lot of actual use cases for closures in this video. This is going to be the topic of some next videos. For now, just sort of bear with me. Okay, so now you fully understand what closures are, and the next thing that we're going to do is we're going to move them out of code. So we're just going to take everything from here. We're just going to move it over there. Okay, like that. And let's have an empty line over here. So now our code is just setting the free variable, and it's just calling the open term. Okay, so the next thing that we're going to do is we're going to make the code a little bit more maintainable. Okay, so first of all, let's switch from this one to I don't know, let's say this one. And in fact, let me remove the other one. Let me fix all of this indentation nonsense. Hold up, let's have it like this, and let's bring it back over here, and let's remove all of that. In fact, this is a subroutine, so let's do this. Let's comment this one out as well. Hold up, like this, like that, and let's comment this one out. Let's bring this down over here. Okay, so I think I didn't break anything, so everything should still work. All right, so because we're using a functional literal, we can't use the named parameters. In fact, it's time that we get rid of them. Let's remove it like this. Okay, and also, I think we can come back to this, to having Sublime on the left and the terminal on the right. So now we just need 50 hyphens, and yet again, we see all of our code. Okay, so we want to make the code a little bit more maintainable, and you know, we don't really like those vars. So what we're going to do is we're going to introduce another variable here, right? So we're gonna convert open term into a def, right? And we're just gonna have a parameter of this, right? So free variable is just gonna come in over here. Now technically this is not a free variable anymore. So in this scope, right, free variable is actually a bound variable. It's bound to this scope. But in this scope, right, well, technically, yeah, in this one, right, it doesn't really matter. So in this function literal, it still remains a free variable. So I'm gonna keep the naming. I'm gonna keep it as a free variable. So now we don't need the var anymore. And by the way, the 1337 goes away, so you sort of see a bit more that it doesn't really matter what the value was in the beginning. Okay, so now we have this, and now we need to move this this here down. So I'm gonna cut it out. I'm gonna put it over here, right? And I'm gonna close this, right? Because open term, when we call open term, it actually returns this function, right? So it's been returned, and we also apply it to an argument right away, right? So this is where you see this is already function curring. Okay, so I'm gonna actually copy that 4 times because it's just faster for me. So we're gonna have a 10 over here, 20 over here, 30 over here, and I'm gonna have 1, 2, and 3, and let's do this. Okay, and that, and everything else should work. And by the way, this is not an open term anymore. This is actually a closed term. So let's have a closed term over here. Closed term. Now this closed term produces a closure, right? So we're sort of arrived at this point where we have a higher order function that is called higher order, not because it takes in the function as the argument, but it actually because it produces another function as its result. And this is function curring. Also, let's now do the subroutine syntax. So we're just going to comment this in, and we're going to copy that, right? Just bring it down. We're going to move this one to the right a little bit. We're going to have a scope around this, and we're just going to return open term. So what you see over here is exactly the same code. In fact, to see the similarity even more, let's do this. While open term equals, let's leave the bound variable on the same line, and let's do this like that. And now the open term is being returned. So now you see the similarity, right? So the top one still works, right? Oh yeah, so now we actually need the type here, right? Like this. Okay, and the bottom one should also work, I think. Right. So remember in the video about subroutines, I think it was video number 6 or so. I said that, you know, if you're declaring a function and the only reason why you declare it is just so that you call it, then use this syntax, right? The subroutine syntax. But if you're declaring a function and you want to do more things with it, right? So you want to treat it as data, you want to pass it around, then use the functional literal syntax. Let's actually keep using the functional literal syntax, and also let's not do this whole complicated thing. Let's just do that again, okay? right? So see, this is much shorter, and in this case we don't need to specify the type because it's actually specified over here. In fact, because the code is so much more maintainable now, we can actually bring it back down into code, right? Because the way you usually structure those tutorials is that we just have this sort of like this framework that introduces those hyphens, and everything I'm doing in the tutorial is inside of code. So I'm gonna try to have all the code inside of this code subroutine, right? So, but this shouldn't change anything. By the way, notice that ever since we removed this variable, ever since we removed this var free variable, so when we started introducing it over here, what is happening here is actually that we're producing 4 different algorithms, right? So let me do I don't know, let's do the last one. So what is actually happening here is partial computation, and we're gonna have a val partial computation equals this thing. Okay, so it should be exactly the same code, right? So it's not exactly the same thing as before. So before we had one closure that was capturing the variable, the place of the variable the place of the var called free variable, right? And we were reusing this closure, so the closure would see the change to this variable. This is a bit more modular. This is a bit more maintainable. So in this case, we're actually creating new partial computations all the time. So this is the one, partial computation number 4, right? So the partial computation number 3 is being created here, where the free variable is a 20. Right, so now it's a bit more clear that, hold up, we need a 4 here, that we're actually creating multiple closures. So maybe the closed term should not be called closed term, it should be called produce closed term. But we're not going to do this in this video. In fact, let me actually revert this thing. There we go. Okay, so we're back at what we started. So the next thing that we're going to do is we're going to learn about function currying syntax in Scala. So Scala supports function currying natively in the syntax. So you see how cool is that when we call it? It sort of looks like we're calling a subroutine with 2 parameter lists, right? And this is exactly what the syntax is going to be doing, right? So so instead of having this, instead of doing function currying manually, right, we can have, let me leave this one here and let me copy that. Okay, hold up. Let me copy that, paste it over here. So what we can do is, instead of doing it sort of manually and producing a function that takes an integer and produces another integer, what we're gonna produce is just an integer. Okay, and over here we're just gonna have free variable plus bound variable. So now when we call it with a second parameter list, and when we define it, we're also going to define it with a second parameter list, right? So we're going to have a bound variable over here, and it's an integer, right? So same as we sort of had before, we still have a free variable and we have a bound variable, but now it's sort of not visible how this whole machinery sort of works in the background. So this is equivalent, right? So this one, and this one, they're all equivalent. In fact, let me comment this out. Right, and we should see it's still working. It works exactly the same. In fact, this is also how function currying is defined in math. Watch my previous video for that. So let's define an uncurried function, right? So uncurried closed term is going to look exactly the same, but it's not going to have multiple parameter lists with single arguments. It's going to have one parameter list with 2 arguments, right? So it's just going to be a comma over here, right? But the code is going to remain the same. In fact, Sublime is keeping jumping like this. Let's do it like that again. 131, and let's go a bit down. Okay, so this is the curried version of the closed term, and this is the uncurried version of closed term. So in math, they say, okay, so instead of looking at a function that has multiple parameters, let's convert it into multiple functions that each take only one parameter, right? So if you want to play with uncurried closed term, we would need to do something like this, and copy that, paste it over here, and now everywhere, I'm sorry, oops, damn it. And now everywhere where we have 2 parameter lists, we're just going to convert it into 1 parameter list, right? And also because now it's only 1 parameter list. Let me run it actually. Okay, something's wrong. What is it like? Oh yeah, I forgot to actually call it. So So it's called Uncut close term. All right, there we go. So now everything should work. The result is exactly the same. And now because it's sort of a in terms of programming, it's a simple function with one parameter list with a bunch of parameters. In this case, 2. We can yet again use the named parameters, right? Don't confuse them with by name parameters, by the way. So the bound variable is this. All right. Everything works exactly the same. All right, so we're actually done with this video. My videos are finally getting shorter. I'm so happy about that. All right, so we learned about what closures are and that they capture sort of the state around them, right? We're going to talk about this a bit more in the next video, but we're going to talk about a way more formal way of reasoning about this computation. We're going to see exactly how the compiler is seeing this whole thing, right? So we talked about closures, we talked about function currying, and this is where our discussion about higher order functions is sort of it's not complete, but you have all the fundamentals now. So now you know about the higher order functions that take functions as arguments, and now you know about higher order functions that produce other functions as arguments, right? And we have function currying over here. It's very beautiful. So in the next video, again, we're going to talk about the environment model of computation, and a few videos after that, we're going to see actually use cases for that. In fact, the whole programming style, there's one programming style called message passive style, and we have another paradigm, object-oriented paradigm, which is built upon of this style. They're all built on top of function currying and closures and higher order functions, and this is what we're going to talk about in the next few videos. Now, technically, you don't really need to understand those formal foundations, right, to become a programmer. I certainly didn't know about that for many years, but I'm really sure that if you do understand them, then it's going to improve the developer inside you, which is what this channel is all about, right? So if you're new here, subscribe if you want to improve the developer inside you, and yeah, cheers, take care, see you next time.